Okay. Same thing, you're identifying this one as an ellipse. Where's your center? 2, 1. So go 2 to the right, up 1. Where are we stretching more vertically or horizontally this time? Look underneath is a 25 under the Y. So we're going to stretch more vertically. So this, I guess you could, the ellipse itself will be more vertical. The major axis is running up and down, however you think of it. So remember that we're going to, one way to remember this is you should find the largest denominator first. So that's going to be your A value, right? A is first. So find that first. And my A is 5. And right away my B is 3. So under the Y is a 5. So I will go up 1, 2, 3, 4, 5. So if I go up 5, I'm adding that to the Y value of the center. So my X is still a 2. All I did is go straight up. But now my Y is a 6. Now if I go down 1, 2, 3, 4, 5, where are we at for this vertex? 2, negative 4. Under your X is a 3. So I go 1, 2, 3 to the left. So I'm subtracting that distance from the X value. So that's going to be negative 1, 1. And I go 1, 2, 3 to the right. That's 5, 1. So we automatically have the ellipse with just putting those points in.
Yeah, until looks like a football. Darling just has to be as beautifully shaped as yours. It looks like an ellipse.
The focus, remember, c squared equals a squared minus b squared. There's only one way you can get this to work. So my c, and a lot of you might get in the habit of going right away to c equals the square root of stuff. You take the largest denominator, which is your a squared, minus the smaller one. And so hopefully it'll start to make sense because you'll just go, oh yeah, Kat said if we add them, we're going to end up outside of the ellipse. You don't want these two dots outside. So we end up getting c is the square root of 16. So that means our distance is 4. If you ended up adding these things together, you're going to get the square root of 34, which is 5 point something. So your dots would end up outside. So again, go along the major axis. We're going up 1, 2, 3, 4. So there's a focus there. I'm adding that to the y value. So it's 2, 5. Oof. 5. And if I go, that's so much better. If I go down 4, 1, 2, 3, 4, this focus is at 2, negative 3. Okay? So again, once you're given that standard equation for the ellipse, I think most of you will do a nice job graphing. The point is you have to get it into that standard form. So here's that completing the square technique, which is a little more difficult because now both variables are squared. So you're actually completing the square twice in one problem. So the first time I do this, I'm going to write out 4x squared minus 8x plus 9y squared minus 54y is equal to negative 49. And what all I'm doing here is I'm kind of, the purple or pink is the x squared stuff and the x first. The y is second, and there's only going to be one constant. Yesterday we picked one variable to stay and everything else went. This time everything stays but the constants. So with the purple or pink here, I have to factor out a 4 from both of those. So when we pull the 4 out, I have x squared minus 2x plus some new number will go there. In the green, I pull the y out, and it's y squared minus 6y plus some new number. And then I have negative 49, and we'll be putting 2 new numbers there. So over here with the x, I have negative 2. I cut that in half. We always divide by 2. That's negative 1. We're careful to put that in parentheses for 2 reasons. 1, we're going to use that number later, and 2, we don't want to mess it up on the calculator. What happens when you square a negative 1? I get 1. So when I put it in this first blank, mentally or literally draw the dotted line to the front. What's 1 times 4? So what I've done over here is I've added 4. So on this side of the equation, what do we have to do? Add 4. Then the negative 6 gets divided by 2, and I get negative 3. When I square that, I get 9. By putting 9 there, double check out front, that's really an 81. So if I've added 81 on the left, I also add 81 on the right. So now I have 4 x minus 1 quantity squared plus 9 y minus 3 quantity squared is equal to, that's 85 minus 49. So
46, isn't it? Oh wait.
the key to this problem is that we always want the ellipse set equal to 1. 10 or 12 of you probably will lose points on the exam because you don't set your ellipse and hyperbolas and stuff equal to 1. The ellipse gets set equal to 1. So when you divide by 36, whenever you divide or multiply in a problem, every term gets divided or multiplied by that number. So every term gets divided by 36. Now there are different ways you guys can handle it. So this is 4 over 36. Which is what? Which is 1/9. 4 over 36 is 1/9. So you guys can put those numbers in, hit math, enter, enter, and it will reduce that fraction. But instead of multiplying, then what we'd be doing is we really are multiplying by 1/9. But in math, we say if you're multiplying by a fraction, you could really divide by its reciprocal. So instead of multiplying by 1/9, I can take x minus 1 and divide by its fraction, or reciprocal I should say, 9. Or if you just reduce this thing, you are left with 1 on top, 9 on the bottom. I don't need to write 1 out in front, just write 9 on the bottom. What's 9 over 36? Again, 9 over 36 is 1/4. Instead of multiplying by 1/4, you can divide by 4 over 1. And the key, though, is I need it set equal to 1. So there's my equation. So I'm going to pause it. You are going to graph the ellipse now. Here's your standard form. You're going to do the graph. Do it as fast as you can. So here's where I left you. We had this equation. 9 underneath 4. So that means we're going to the left and right 3, up and down 2, my center was at 1, 3. So I put my center in at 1, 3. Then everything, all the rest of the dots are built off the center. So go to the left 3 and the right 3. So you should have -2, 3 and 4, 3. Up and down, I've got the co-vertices labeled 1, 5 and 1, 1. Now, when you do the focus, this is probably the one time I just think I don't worry too much about you guys reducing the radical or simplifying the radical. But I think the easiest thing is when you find your C value is the square root of 5, if you add it or subtract it to the x of the center, notice how I wrote it. I just said 1 plus the square root of 5 and 1 minus the square root of 5. If you went to the decimal, I would understand in this case, but that's how you can do it. That's the easiest. You don't have to do any work. You just 1 plus it, 1 minus it. Okay.
Hold up.
Drop.
There's a thing called eccentricity, which is talking about how oval or circular the ellipse is. If E is really small or close to 0, it's a circle. If E is really close to 1, then it's more elongated. And so, the orbit of the moon has an eccentricity of 0.0549. To me, that's really close to 0, right?
Yes.
But you always see the science geeks always do this oval thing. They don't. It should really be a circle. The moon almost does a circle around. It's not a elliptical shape in its orbit, in my opinion, mathematically speaking. I think they're wrong, just like with Pluto, getting rid of it and all that. All right, right now what I want you to do is complete the square on your own. So you're going to do the completing the square technique. Do not graph this until we know that you have the right equation. So get the right equation first.
Why are you showing us?
I thought people said they were ready.
Jeff was ready.
So, bring the x's to the front. I have to factor out a 9. With the y's, you have to factor out the 4. So when you end up taking the 4 divided by 2 is 2, square root is 4. I added a 4, but that's really a 36, so I added 36 over there. With the y value, I take the -6 divided by 2. I get -3, square root is 9, but when I put 9 in there, that's also a 36. So with the -36 plus 36, we're left with 36. You always need it equal to 1, so you're dividing everything by 36. Final equation, oops, that doesn't work. Final equation is right there.
You want us to sketch that?
We are going to sketch graph, but I want to make sure you are here.
Okay. There. Hold on, Jeff. What about this? I know it back here.
Almost Jack. Rachel's not here. She's just so mean to you that you can't.
She convinced
My center now, this time is -2, so you have to move 2 to the left, up 3. So your center will be at -2, 3. Under the y, we're moving more under the y, right? So up and down 3. So your A value is 3. So you go up 3, down 3. So you're not changing the x value, you're changing the y. So you're at -2, 6 and -2, 0. Under your x is a 4, so when you square root that, you get 2. So you're going 2 to the right, 2 to the left. 0, 3, -4, 3. That would give you the elliptical shape that you need. The last thing is you find your C value again, subtract big minus small, and you get the square root of 5. I'm going to add that to the y value. So when you look at my focus on top, the x value stays the same because it's all in a line at -2, but then I just said 3 plus the square root of 5. And the bottom one is -2, 3 minus the square root of 5. Off to the side, I showed you eccentricity. You end up getting the C over A, so it's 0.745. I would say that's closer to 1 than it is to 0. So we are a little more elliptical shape or oval than we are circular.